respectively. Find the resultant of this force system. Find the resultant of this force system. Gaurav Dikshit, you please tell me what you have written.
Sir, my name is Gaurang Dixit, sir.
अच्छा, गौरांग, हाँ गौरांग, अच्छा ठीक है.
So the question is, ABCD is a square of side 6 meter. Forces
Good.
acting along AB, BC, CD, DA, AC and DB are 1.5 kilonewton, 3 kilonewton, 12 kilonewton, 7.5 kilonewton, 7.5 root 2 kilonewton and 3 root 2 kilonewton respectively. Find the resultant of the force system.
Good, good, good. You solve it.
The resultant of the forces as in along.
You have to find the resultant of the force system.
Along the center axis.
No, if you will take the AB, you will take some reference plane. If you are taking AB as x-axis, so take it at x-axis positive direction. That depends on you. So for how much resultant force is coming, I have told you find the resultant of the force system. Maybe force value you will get, and also you will get a moment, because all the forces are not collinear and concurrent. That you have to keep in your mind, because here force system is coplanar. That is okay, but collinear is not. So here force system is coplanar, non-concurrent. So you will also get a resultant force and moment also you will get. So whatever you are getting, you tell me.
The resultant force is 0.
Resultant force is 0. Good.
Sir.
हाँ बोलिए.
Sir, can you repeat the question? I was in the wrong meeting.
ओह सॉरी. क्या ये हम सुबह एक मीटिंग डाले थे, हमसे लगता है गड़बड़ हो गया. क्या हुआ था उस मीटिंग में?
सर उसको मैंने ज्वाइन किया,
then we start leaving.
अच्छा, वो भी तुम लोग के पास लिंक पहुंच गया था?
हाँ सर आ गया.
मीटिंग ऑन था, हम लोग कोई लेक्चर 1 भी ज्वाइन कर लिया था, हम भी ज्वाइन कर लिए थे.
नहीं, हमको एक लड़का क्या बोला, ये सर लिंक नहीं आया है. तो हम सोचे जो घर से जो लिंक दिया, हम कल लिंक देना भूल गए थे. तो घर से जो लिंक दे रहे थे, जल्दीबाजी में हो सकता है कुछ दूसरा क्लिक हो गया होगा. तो चलते समय दिए थे, इसीलिए हम फिर से दूसरा लिंक आकर के कॉलेज में दिए. तो इसीलिए कोई प्रॉब्लम नहीं. गौरांग दीक्षित.
Yes, sir.
चल. अच्छा, okay, leave it again. I am telling you the problem. ABCD is a square. ABCD is a square of side 6 meter. Forces acting along ABCD is a square of side 6 meter. Forces acting along AB, BC, CD, DA, AC and DB. Forces acting along AB, BC, CD, DA, AC and DB are 1.5 kilonewton, 3 kilonewton, 12 kilonewton, 7.5 kilonewton, 7.5 root 2 kilonewton and 3 root 2 kilonewton respectively. Find the resultant of this force system.
Sir, is it 0?
Yes, sir, it is 0.
What is 0? You
Resultant.
tell me.
Sir, the
Resultant.
resultant.
Resultant force is 0. And also you have to calculate the moment, because this force system is coplanar, non-concurrent. So also you will get
72
a moment.
kilonewton per meter
72 kilonewtons per
per meter. 70 kilonewton meter.
72 kilonewton meter.
Meter.
Yes, sir, 72.
72 kilonewton meter. Direction also you have to tell.
Clockwise. With
Okay.
respect to.
Right. Right, clockwise. ठीक है, और लोग जो थोड़ा लेट आए हैं उनको भी सॉल्व करने दीजिए, अभी प्रॉब्लम दिए हैं, लेट देम टू डू. ये इज स्क्रीन विजिबल टू यू?
Yes,
हेलो.
sir.
हाँ, एक प्रॉब्लम हम इस पे ड्रॉ कर रहे हैं, जस्ट यू let them to solve the other students, then I will at that time I am doing. हेलो हेलो हेलो. क्या चीज का रिक्वेस्ट? अच्छा, कौन सा तुम्हारा कौन सा ट्यूटोरियल है? सेक्शन ही तो सभी लड़के का नाम ऐड है. तुम्हारा क्या है रोल नंबर? अच्छा, 10533. ओके. अच्छा, तो किसी और फ्रेंड है उससे कर लो, ठीक है? हम आज प्रॉब्लम सॉल्व कर... नहीं नहीं, उसी से पूछ लो. अभी दूसरा लिंक क्रिएट किए हैं, उसमें कुछ प्रॉब्लम आ रहा था. ठीक है, अभी हम 95 में किए हैं, उससे पूछ लो. ठीक है, ठीक है. हाँ, मेरे पास है, अभी हम ऐड कर देते हैं, कोई दिक्कत नहीं. ठीक ठीक. So uh, students, Gaurvang, Gaurang,
Yes, sir.
have you solved that one problem?
Yes, sir.
First problem.
Yes, sir.
How much moment you are getting?
72 kilo Newton meter.
And also you tell the direction.
So from
Clockwise.
the plane I have taken, it's clockwise.
So you have to write this.
Okay, sir.
Okay. So you write another problem. I have given you the diagram of this. This is a you write whatever the missing data I will tell to you. A circular log of weight. Circular log. This is circular log of weight 1200 Newton and radius 18 centimeter. A circular log of weight 1200 Newton and radius 18 centimeter is supported by a pair of bracket. Is supported by a pair of bracket. Bar
Sir, radius how much?
radius 18 centimeter. Radius 18 centimeter is supported by a bracket. Is supported by a bracket. By a pair of bracket. Okay. One minute. Bar PN hinged at P. Bar PN hinged at P and held by a string MN and held by a string MN is 57 centimeter long. Is 57 centimeter long. Bar PN hinged at P and held by a string MN is 57 centimeter long. To reduce to induce minimum tension at Mn, to induce minimum tension at Mn, comma, determine the value of 2 theta. Determine the value of 2 theta. See here, this angle is theta. I am writing here. 1 minute. This simple theta. So this is theta and this is also theta. Okay, and this is connected to the center here. Center of this log. Circular log is there. So whatever the center is there. So from this center, this radius is connected. So this angle will be theta. And this angle is also theta.
Excuse me,
1 minute. 1 minute you wait. Tell me. Tell me.
sir, I was disconnected. That's why I was asking for question. Someone sent me
Okay,
that.
again I am repeating.
Sir, someone sent me that.
Okay, again I am repeating.
Sir, that log is touched with that string mn, or is it
No, that is not touching.
okay?
You 1 minute. This way. Is it clear to you?
Yes, sir.
You extend it here.
Sir, PN is 57 centimeter. PN.
No. Again I am repeating. You check it.
No, sir. Just
A
I have to
circle.
clarify whether
Okay,
MN is
again I am repeating. Some students have not written properly.
okay, sir.
A circular log of weight 1200 Newton and radius 18 centimeter is supported by a pair of bracket bar PN hinged at P and held by a string MN is 57 centimeter long. MN is 57 centimeter long. To induce minimum tension at MN, determine the value of 2 theta for equilibrium. This line is connected from center of this log. So this bar is inclined with this center of radius is theta, and this is also theta. So determine the value of 2 theta for equilibrium. Full stop.
Sir, we have to take that PN bracket as ideal, means its mass is to be taken negligible.
No, I am telling you, consider all surfaces smooth. Also find the value of minimum tension. What you are telling? Tell me.
I was saying that PN is the bracket, but means we have to consider it as an ideal body with negligible mass.
Negligible mass. Only you have to consider the mass of the log.
Okay.
Sir, the angle 2 theta is 60 degrees.
Angle 2 theta is
60 degrees.
So you have to find the minimum tension.
Yes,
So
sir.
calculate the minimum tension.
Sir, 1515.78.
1000
515.78.
0.78. Let the other students also should calculate.
Yes, sir.
Length of the bar PN is 57 centimeter. Because if you will see the problem, to induce minimum bar PN is held at P by a string Mn is 57 centimeter long. So bar Pn is 57 centimeter long.
Excuse me, sir.
Yes,
Sir, here is the point M also fixed.
M is also fixed. This is held by a string. So if you tie with a string, so M is fixed. Mn is a string.
Okay, sir. Okay, got it. Okay, sir.
Point P is only hinged. So if you will lose the string, that P is a hinged point, so it will, that theta will increase or and that it will vary. Okay.
Yes, sir.
But for a fixed angle of theta, that Mn length will be fixed. But Pn length is 57 centimeter. In the problem, if you will read the problem, you will get that Pn is 57 centimeter long. So first you draw the free body diagram. Calculate the summation, because weight is acting in the vertical direction, so calculate the summations of all the forces in the vertical direction is equal to 0. And then you calculate the draw perpendicular to Pn from center of gravity G of the log till that point is J. So calculate the length Pj. So Pj will become, radius is 18 centimeter. So you will get around, how much you will get? Pj and Pm. You calculate. Then you calculate the moment about point P, because this is hinge. So it will move. So let the torque be T. So T into Pm is equal to reaction at J point, because weight will act here, Rj into Pj, reaction at J and into Pj. So from here you will get the T in the form of theta, 2 theta. So you have to minimum
we are
value.
unable to see your screen.
No, I have shared the slide. Some students have.
Screen is visible, sir.
Is it clear?
Yes,
Hello?
now it is.
So whatever the T value you will get, so lower in the denominator you will get something sine cos in the form of 2 theta or theta. So you have to maximize the value. So differentiate it, make it to the 0, and whatever the theta you will get. So for that one theta, t value will be become minimum. This is the procedure here you have to do. So do the calculation and tell me. So this is the center. From center, you draw a line. I am showing here. You draw this line from the center and write that point is, give some name J.
Så alla var snäll
This is
fastline
J. So here it will become, this is the 2 theta it will become. So from center here and this, if you see, and also you draw a perpendicular here that you give the name Q. And this reactions will be become Rj. So first you calculate Rj. So Rj sine 2 theta is equal to 600. If you will draw the free body diagram, this will come in this one way. Here, this is bar. You write this P N M. So you give this arrow and right here, this is T you have to find. Write this N, this is P, this is M, and this is T, because tension is acting in this one direction. This PN length is 57 centimeter, and RJ is acting here, perpendicular to this direction, right here. Here J point you write. So Rj you will calculate, this will become 600 by sine theta, summation Fy is equal to 0. So Rj sine 2 theta, if you will draw here, Rj sine 2 theta is equal to 600. That reaction force is there. If you calculate, so Rj is equal to 600 sine 2 theta, and Pj, if you will calculate, then it will become 18 cot theta. 18 cot theta, and Pm is equal to this Pm. This length will become 57 cos 2 theta. So system is in equilibrium. So using moment equilibrium at P, because this length will vary, because here P is hinged. So you have to calculate the moment about P. So this T will act, this tension will create a torque. So T into perpendicular length will become Pm. So T into Pm is equal to, this tension will be balanced by Rj into Pj. So Pj you calculate, that will also be Pj you have calculated that 18 cot theta. So equation will become T into 57, T into 1 minute. 1 minute. Yes. T into 57 cos 2 theta is equal to 600 by sine 2 theta into 18 cot theta. Derive this and make it the equation in the form of T. And T you have to attain the minimum value. So whatever the numerical value divided by something, 2 into sine square theta into cos 2 theta, this you will get. So sine square theta into cos 2 theta have to get the maximum value, then the T will become the min value. So differentiate it, d by d theta of 2 sine square theta into cos 2 theta is equal to 0. So from there you calculate the theta, and for that one theta you will get the value of that one. This is the procedure to find that one. So you tell me the theta, how much you have got? Praveen Dikshit,
Yes, sir. Yes, sir.
how much you have got theta? Have you understood?
Yes,
You
sir.
have to
I've got
calculate?
theta equals to 30 degree and 2 theta will be 60, I guess.
Good.
According to me.
And T minimum, how much you are getting?
30 minimum, I was just going to calculate.
Okay. Nikhil Verma? Nikhil Verma,
Yes, sir. Yes, sir.
how much theta you have got?
Sir, 2 theta is equal to 60 degree and tension is equal to 1515.78.
T tension is equal to how much?
1515.78.
1557.8. Okay. T minimum equation, you tell me how much you have got?
Sir, T was equal to WR upon 2L cos 2 theta sine square theta. So I put theta in that equation.
So and W, how much you have put?
1200.
No. That will be shared by the 2, na?
Yes.
So it will become 600.
Oh, okay, sir. Yeah, understood.
Okay. So how much you are getting?
Sir, Sir, 757.89.
That is correct answer.
Okay, sir.
757. Have you understood how you have to calculate?
Yes, sir. We got WR by 2L cos 2 theta sine square theta. So to maximize the tension, 2L cos 2 theta sine square theta should be minimum.
Minimum. Just you have to differentiate it. You have to form the equation, and whatever they are asking in that one way you have to do it. Okay?
Yes, sir.
Okay, so time is over. In next tutorial class, we will do the problem related to truss. Okay. Hello.